In the last class, we have learned about the cardinal points of a coaxial optical system of two thin lenses separated by distance. So, in that, we learned two principal points and two focal points, and we gave them name as the first principal point and second principal point. And for focal, it is again the same, first focal point and second focal point. So we found what is the position of first and second principal points and what is the position of first and second focal points. So we understood what is alpha 1, alpha 2 and beta 1 and beta 2. So in this class, let us try to solve the problems which are based on the unit 2, that is cardinal points chapter. So let us start with the first question which is given in your textbook. So it says calculate equivalent focal length of two thin lenses of focal length 0.4 meters separated by distance 0.3 meters. So if you see here what is given, the focal length of two thin lenses is given and the separation between the two thin lenses is again given to us. So the data given is F1 and F2. So both these are equal, so that is the 0.4 meters. So both these quantities are in the same unit, so no need to change them to centimeter or millimeter. So they are in meters, so let us keep them in meter itself. So the next is separation distance. So separation distance is denoted by small d, that is 0.3 meter. So we have found the formula for the equivalent focal length of two thin lenses when they are separated by finite distance. So the formula is 1 by f is equals to 1 by f1 plus 1 by f2 minus d divided by f1 f2. So what is d here? D is the separation distance between two thin lenses and f1 f2 are the focal length of the two thin lenses. Now let us substitute the values which are here in this equation. So that is 1 divided by f1 is 0.4 meter plus 1 divided by f2 is again 0.4 meters minus d is 0.3 divided by 0.4 multiplied by 0.4. So this gives what? 1 by 0.4 plus 1 by 0.4 minus 0.3 divided by 4 4 16, so that is 0.16. So we have 1 by 0.4, 1 by 0.4 and 0.3 by 0.16. So this can be written as, so this first two terms can be written as 2 by 0.4 minus 0.3 divided by 0.16. So 2 ones, 2 twos. So 0.2 is left. 1 divided by 0.2 minus 0.3 divided by 0.16. So if you solve this, then you get the value as 3.125. So this is equals to what? This is equals to 1 by f. So now if you want f will be what? 1 divided by 3.125 and that is equals to 0.32 meters. So f is equals to 0.32 meters. So for the question which is given here, we found what is the equivalent focal length. So this equivalent focal length is for what? That is for the two thin lenses which are separated by the finite distance. So the distance here is 0.3 meters, so which is given in the question itself. So from the question we got to know what is f1 and what is f2 and what is d. So directly you need to substitute these two values in the equation that we have already derived in our last class. So in our last classes we derived this equation And so if you substitute these two values in this equation, then you directly end up getting the value 1 by f as 3.125. So now if you take f to the left hand side, then what will be left? 1 divided by 3.125, and that is equals to 0.32 meters. So this is the answer, or this is the equivalent focal length of two thin lenses which are separated by distance 0.3 meters. So as simple as that. So you have the formula, directly substitute the values which are given in the question, then you will get the focal length. So now let us move to the second question, that is, so which is again given in your textbook. So which is a convex lens of 0.1 meter focal length. So you have convex lens, so which has got 0.1 meter focal length. So this is placed in air from a concave lens of focal length 0.2 meters. So you have convex lens which is kept in air, which has got the focal length 0.1, and you have concave lens. So you have two different lenses, convex and concave lens. These two lenses are separated by some distance, that is 0.05 meters. So these two lenses are kept in a air medium. Now find the distance between the two principal points of the combination. So what he is actually asking what is alpha 1 and alpha 2. So alpha 1 and alpha 2 is unknown to us. So let us write the data. So data given is, so what is given? F1 is 0.1 meters, and what is F2? F2 is 0.2 meters, and D is 0.05 meters. So you have the data F1, F2 and D. So let us see the equation. So the equation that we need to use here is, that we have to use for this question is F1 F2 divided by F1 plus F2 minus D. Since the medium which is given to us is air medium, so D by N here is 1, so you need not to worry about the refractive index of the medium, so that is N. So now let us substitute the given values in the formula which we have. So F1 is what? F1 is 0.1 and F2 is what? Minus 0.2. That is divided by F1 is 0.1 minus 0.2 minus 0.05. So this will be what? Minus 0.02. And here you have 0.2 minus 0.1 is minus 0.1. So minus, or if you add these two terms, so you have minus here, minus here. So 0.2 plus 0.05 will give you 0.25. So 0.1 minus 0.25. What left is minus 0.02 divided by minus 0.15. So if you subtract minus 0.25 in 0.1, then you get minus 0.15. So minus will get cancelled. What remains is 0.13 meters. So this is F. So that is equivalent focal length. So how did you find? So you have used the formula F1 F2 divided by F1 plus F2 minus D. Now substitute the given data. So 0.1 multiplied by 0.2. So divided by 0.1 minus 0.2 minus 0.05. So if you solve this, you get F is equals to 0.13 meters. So that is, so you found what is the focal length or the equivalent focal length of two thin lenses which are separated by a distance 0.05 meters. So now we are supposed to find the position of first principal point. So the formula for first principal point alpha 1 is equals to what? df by f2. Or you can also write this as capital F, since we have taken here f as small, I have written small f. So now if you substitute the value of d, so d is 0.05 multiplied by 0.13 and this is divided by f2. f2 we have value 0.2. So alpha can be written as alpha, since the negative here, so alpha will be the negative value, that is 0.0325 meters. So it is situated at a distance 0.0325 meters to the left of the first lens. Now let us find the alpha 2, that is df divided by f1. So d is again 0.05, that is multiplied by f is 0.13 and this is divided by f1. So f1 we have 0.1 meters. So now if you solve, so here for the second lens this will be negative sign, so that means we get 0.065 meters. So alpha 2 is 0.65 meters and alpha 1 is 0.0325 meters. So the next question is, two thin convex lenses, each of focal length 30 cm are placed coaxially with 15 cm distance between them. Find the equivalent focal length and the position of principal points of the combination. So in this question he has mentioned two thin convex lenses. So for these convex lenses he has given the focal length. So the focal length for first convex lens is 30 cm and the focal length for second convex lens is again 30 cm. And these two lenses are separated by a distance 15 cm. So D is equals to 15 cm. Now what he is asking, find the equivalent focal length and the position of principal points of the combination. So we have to find F and the position of principal points of the combination. So first let us try to find F, then we'll go for position of principal points of the combination. So now these two quantities are in centimeters, so you can convert these two into meters. So 30 centimeter will be equals to 0.3 meters and D 15 centimeter is equals to 0.15 meters. So what we have done, we have converted centimeter to meter. Now let us apply the formula. So for equivalent focal length of two lenses which are separated by distance can be written as F is equals to F1 F2 divided by F1 plus F2 minus D. So we know what is F1 and F2, we know what is D. So if you substitute, what you will get, 0.3 multiplied by 0.3 divided by 0.3 plus 0.3 minus D is 0.15. So if you solve this, what you will get, 0.3, 3 is 9, so 0.09 divided by 0.3 plus 0.3, it is 0.6, minus 0.15. So you have f is equals to 0.09 divided by 0.6 minus 0.15. So now if you solve this, you will get 0.09 divided by 0.6 minus 0.15 is 0.45. So 1 if you remove, it will be 5. So here 5 is there, so 0.05. Now, so what will be f? F will be 0.2 meters. So why 0.2? Because 9 ones, 9 5s, 1 by 5 is 0.2 meter. Now let us find the position of first principal point and the position of second principal point. So he has asked, find the position of principal points. So let us find that. The first is alpha 1 and the second is alpha 2. So alpha 1 and alpha 2 we have to find. Let us write the equation for alpha 1. Alpha 1 is df by f2. So this small f here denotes the equivalent focal length of two thin lenses which are separated by finite distance. So d you know, so d is 0.15 meters, which is multiplied by 0.2 meters divided by f2 is 0.3 meters. So 15 2's 30. So if you solve, so answer will be 0.1 meters. So alpha 1 is 0.1 meters from the first lens. So let us find what is alpha 2. Alpha 2 is again df by f1. So you will get the same. So minus 0.15 multiplied by 0.2 divided by 0.3. So for this you get a negative sign, that is alpha 2 is equals to minus 0.1 meters. So this is minus 0.1 meters to the left side of the second lens. So the first is 0.1 meter from the first lens and for minus 0.1 to the left side of the second lens. So this is the problem and the solution. So you have two thin lenses which are separated by a distance 15 cm, which has got a focal length of 30 cm. So now for this he has asked us to find the equivalent focal length and the position of principal points. So for equivalent focal length we know the formula, f is equals to f1 f2 divided by f1 plus f2 minus t. So the problem is very much direct, so you can use the direct values, substitute the values, and you can get the equivalent focal length of two thin lenses. Now after this you have to find what is alpha 1 and what is alpha 2. So alpha 1 is df by f2, so that is positive, and alpha 2 is minus df by f1. Since both the focal length for the two lenses is same, so we'll get alpha 1 and alpha 2 the same magnitude but with different direction. So alpha 1 is 0.1 meters and alpha 2 is minus 0.1 meters. So this is the solution for the third question, that is two thin lenses which are separated by a finite distance. So the next question here is to find the equivalent focal length. So this is again a direct question. So here you have to find the equivalent focal length of two thin lenses, so which has got the focal length of 0.2 meters and are separated by a distance 0.3 meters. So here again the focal length of the two lenses is same, so that is 0.2 meters or 20 centimeter. So for this system you have to find the equivalent focal length. So the data given is f1 is equals to f2 is equals to 0.2 meters, and now d is 0.3 meters. So for this we have to find what is equivalent focal length. So equivalent focal length for the system can be written as 1 by f is equals to 1 by f1 plus 1 by f2 minus t f1 f2. So substitute the values of f1 and f2 in the equation. So what you get, 1 by f1 is 0.2 plus 1 by f2 is again 0.2 because the focal length of two thin lenses are same. Now what is d? D is 0.3 meters divided by 0.2 into 0.2. So 0.2 plus 0.2 is 2 by 0.2 minus 0.3 divided by 0.2 multiplied by 0.2 is 0.04. So you have 1 by f is equals to 2 divided by 0.2. So 2 by 0.2 is how much? So 10 goes here. So 10 minus 0.3 divided by 0.04 is 7.5. So 10 minus 7.5 is 2.5 and that is 1 by f. So if you need f, it will be what? 1 divided by 2.5, that gives f is equals to 0.4 meters. So finally you found the equivalent focal length for the two thin lenses which has got the focal length of 0.2 meters and which are separated by a distance 0.3 meters. So equivalent focal length here is 0.4 meters. So f is equivalent focal length. So this is the solution for the fourth question. Calculate equivalent focal length of two thin lenses, each of focal length 0.2 meters separated by a distance of 0.3 meters. Next question is, two thin lenses of focal length 0.3 meters and 0.1 meters are placed 0.25 meters apart in air. So here they are mentioning the medium is air medium, so the refractive index for this medium will be what? So it will be 1. N is equals to 1 for the air medium. Now he is asking calculate the position of the principal points. So what we have to find? Again we have to find the alpha 1 and alpha 2 for the system of two thin lenses. So data given is, so the focal length of f1 is 0.3 meters and f2 is 0.1 meters, and these are separated by a distance of 0.25 meters in air. So n here will be 1. So for equivalent focal length of two thin lenses which are separated by distance d can be written as f is equals to f1 f2 divided by f1 plus f2 minus d. So f1 here is 0.3 meters and this is multiplied by f2 is 0.1 meters. So f1 is again 0.3 plus f2 is 0.1 minus d is 0.25 meters. Now 0.3 multiplied by 0.1 is how much? It is 0.03. So 0.3 plus 0.1 is 0.4, which is my subtracted with the number 0.25. So 0.03 divided by 0.15. So 3 ones, 3 5s, 15. So 1 by 5 is again 0.2 meters. So f is equals to 0.2 meters. So the equivalent focal length for the two thin lenses with a focal length 0.3 meters and 0.1 meters is 0.2 meters. So now next is we have to calculate the position of principal points. So again you have to find what is alpha 1 and what is alpha 2. So we know alpha 1 is equals to df by f2 and alpha 2 is df by f1. Now d is 0.25 which is multiplied by f, that is 0.2, so which we got here, divided by f2, focal length of second lens, so that is given to us, so that is 0.1. Now 25 to is 50 divided by 0.1, so that gives 0.5 meters. So alpha 1 is 0.5 meters to the right side of the first lens, so it is a positive value. Now for alpha 2 is equals to d is again the same value 0.25 which is multiplied by f is 0.2 divided by f1 which is 0.3. So alpha 2 will be what? So here there is a negative sign. So alpha 2 is minus df by f1. So alpha 1 is df by f2. So there is a negative value here. So minus 0.25 multiplied by 0.2 divided by 0.3. So this gives minus 0.05 divided by 0.3. That means alpha 2 is equals to minus 0.167 meters. So this alpha 2 is left side of the second lens and alpha 1 is right side of the first lens. So finally we found what is equivalent focal length for the system of two thin lenses and what is the position of the principal points. So to do that, what we have done, we have first wrote what is the focal length of each lenses. So for first lenses, the focal length is given as 0.3 meters and for second lens, the focal length is given as 0.1 meters. So these two thin lenses are separated by a finite distance of about 0.25 meters. So this distance is larger when compared to the focal length of two thin lenses. So with this in mind, so we wrote the equation to find the equivalent focal length for the two thin lenses. So that is equals to f1 f2 divided by f1 plus f2 minus d. So if you solve this, so what you will get, f is equals to 0.03 divided by 0.15, that means f is equals to 0.2 meters. So we found what is the equivalent focal length. So now with this data we have to find the position of the principal points, so alpha 1 and alpha 2. So formula for alpha 1 and alpha 2 we already know, so substitute the values and find what is alpha 1 and alpha 2. So that is the solution for the problem 5.